Hi guys, welcome to your Unit 11, Lesson 1 notes on excluded values. Oh, how sad, excluded. By the end of the day, you will be able to identify excluded values in a rational expression. So let's go over 2 quick math facts, real quick. A rational number is any number that can be written as a fraction. Remember, a fraction is something like a over b, just like that. That's a rational number. And finally, we cannot divide by 0. If we have like 5 divided by 0, for example, we say that is undefined. We don't have a definition for it. We can't do it. We cannot divide by 0. Because we cannot divide by 0, then, an excluded value is a value assigned to a variable that will result in a denominator of 0. So if we have, a divided by b, and b is 0, then that's an excluded value. Say our excluded value is 0. So to find excluded values, what you want to do is you want to set your denominator equal to 0. Then solve for your variable. So let's do that right away. Here, to find an excluded value, for each rational expression, we want to set our denominator equal to 0. So remember that your denominator, let's make it purple. No, green. We'll go with green. Your denominator equal to 0. So here our denominator is this bottom part. This bottom part, this bottom part. Okay, so we're going to set that equal to 0. Say what happens when 2 plus a equals 0? Well, if we want to get a all by itself, I'm going to subtract 2 from both sides. Say a equals -2. So -2 is our excluded value. Because, let's plug it back in and see what happens. If we have -2 for a, then we say 5 times -2 divided by 2 plus -2. Well, that's -10 divided by 0. Oh no, we can't divide by 0. Don't do that. That's undefined. Okay, right. Number 2. We're going to set our denominator equal to 0. So what happens when b times b minus 4 equals 0? Well, now we've got 2 factors. So we need to split this guy up. So we're going to say what happens when b equals 0 and when b minus 4 equals 0. Well, here, b equals 0. Done, I solved it. And on this side we add 4, we add 4. So b equals 4. So we actually have 2 excluded values here. Our 2 excluded values, and we'll just leave it like that, sure. b equals 0 and b equals 4. Or if you would rather write, you can say b equals 0, 4. Those are excluded values. You know, guys, we should probably say, no, we're good. We're going to leave it. I'm not going to make life complicated. And one more. To find excluded values here, we're going to set our denominator equal to 0. So c squared minus 25 equals 0. Okay, well, let's get c all by itself. We'll add 25 to both sides, giving us that c squared equals 25. Oh, we just solved radical. We just solved radical equations, and we solved quadratic equations by taking square roots. So here we go. Those are going to cancel out. C equals plus or minus 5. So there you go. We can't have positive 5 and we can't have negative 5. We found our excluded values. Way to go! Now, that's great, but why is this important? Well, you remember, since we cannot divide by 0, the domain of a function is limited. What? This goes all the way back to graphing, to domains of functions. Quick review. What's a domain? A domain is all the x values of a function. That said, if we have 3 functions, oh look at these 3 functions right here, then there are some x values we cannot plug in here or else it'll break our function. Oh no! So to define the domain of each function, we need to set our denominator equal to 0. Once we have our denominator set equal to 0, we're going to find our excluded values. And once we find our excluded values, we will use the following phrase. We'll say, the domain is x equals all real numbers, or just kidding, I got ahead of myself. The domain is all real numbers where x does not equal whatever our restricted or our excluded values are. So let's do that. Okay, first we need to set the denominator equal to 0. X minus 3 equals 0. So we go, okay, x minus 3 equals 0, add 3. Therefore, x equals 3. That's our excluded value. So we say the domain is all real numbers, but x is not equal to, redo. The domain is all real numbers, but x is not equal to our restricted value of, not restricted, our excluded 3. So say x is not equal to 3. Super. That's it. That is our answer. Let's do it again. First step, we need to set our denominator equal to 0. Here's our denominator. Let's set that equal to 0. So we have x times x plus 2 equals 0. Oh, now we have 2 factors. Let's split them up. So we have x equals 0. That was fast. And x plus 2 equals 0. Well, that's solved. Minus 2 minus 2. X equals negative 2. Okay, so again here, our domain is all real numbers, but instead of 3, x cannot be 0, or, gonna run out of room, negative 2. Apparently I can't draw a rectangle today. Better. All real numbers with x is not equal to 0 or negative 2. Wait, why? Why does this make sense again? Well, let's see what happens. What if x is equal to 0? Then we'll get 3 times 0 over 0 times 0 plus 2, which will give us 0 divided by 0 times 2. Nope, can't do that. Can't divide by 0. Okay, well, let's try again. What if x is negative 2? 3 times negative 2 divided by negative 2 times negative 2 plus 2. That's a lot of 2's. Who wrote this question? Oh, I did. So we have negative 6 divided by negative 2. Wow, that looks really good so far. Times 0. Okay, cool. So we have negative 6 divided by 0. Shoot. Can't do that. Undefined. Not gonna work. And finally, one more. To find the domain of this function, we're going to set its denominator equal to 0. So we have x squared minus x minus 6 equals 0. Ooh, that's super complicated. If only there were a way to simplify this quadratic expression. Oh yeah, let's factor it. So when we're factoring, we are looking for 2 numbers that multiply to negative 6 and add to negative 1. So I'm going to do my box guy. We need them negative x squared. We got negative 6. So I know we need x. We need to find 2 numbers to fit in here. Okay, well, if we do Let's try -3 and 2. That'll give us -3x plus 2x is -x. That's what we want. So we have x minus 3 and x plus 2 equals 0. Now that we have that, we can go ahead and split her up, giving us x minus 3 equals 0 and x plus 2 equals 0. Well, we add 3 to both sides, giving us x equals 3, and we minus 2 from both sides, giving us x equals -2. There you have it. Those are our excluded values. Now that we have our excluded values, we know what x cannot be. Man, x really has something against -2's in this lesson, doesn't it? Oh well. So the domain again is all real numbers, but this time x cannot be 3 or -2. That's it. All set. Way to go, guys. Remember our steps here. We want to set the denominator equal to 0, find our excluded values, and then say the domain is all real numbers except for our excluded values. Cool. Well, I hope you enjoy your wonderful, phenomenal homework, and also that you never feel excluded.